Good morning, ladies and gentlemen, and welcome to Math Mountain. This is a second episode in our calculus series, and our topic is graphical approaches to limits. This example is very much like the last one from the previous video, and if you want, stop the video and see if you can find the right and left side limits, and then the limit of f of x as x approaches 1. Now we're going to start by considering the left side limit in this problem, or the limit of f of x as x approaches 1 from the left side, or from values of x that are less than 1. Okay, so we can see that as our function gets closer and closer and closer to 1, that our y value is getting closer and closer to -1. So we would write that the limit as x approaches 1, and remember we use the negative for values of x that are less than 1, of f of x equals, and we can see that that equals -1. We're approaching -1. Now let's take a look at the right side limit. Now the right side limit, we're looking at values of x that are greater than 1, or coming from the right. We're approaching x equals 1 from the right side. So this would be our right side limit over here. And we would write that where we can see that as x is approaching 1 from the right, we can see that the y value is approaching 1. So we write that limit as the limit as x approaches 1, and we use the positive exponent in the exponent position to indicate from values of 1 that are greater than x equals 1 of f of x, and we saw that that was 1. Now let's take a look at the overall question. Find the limit as f of x approaches 1. Okay, recall that we have to consider the left-hand side limit and the right side limit to determine this. So our left side limit equals -1, and our right side limit equals +1. So the limit, the overall limit of f of x as x approaches 1. And let's point out here that the left side limit does not equal the right side limit. So the limit of f of x as x approaches 1 does not exist. Our next example is to find the limit of 1 over x squared as x approaches 0. This example is a little different because our f of x at x equals 0 does not exist. We have an asymptote there at x equals 0. And our left side limit and right side limits are not finite. To help see these limits, we will bring in a table, and let's take a look at our table. First, we're going to look at the left side limit in the table, or as the x values approach 0 from values of x less than 1, or at less than 0. And we'll notice that our y values are getting bigger and bigger. In fact, very big. What is that? 100 million by the time we get there. And on the right side, our right side limit, we're approaching a very big number. And you might suspect that that number, and you'd be correct, that that number is going to continue to get bigger and bigger. That y value is going to continue to get bigger and bigger. And it is approaching infinity. In fact, it's approaching positive infinity from the left and from the right. So we would write these limits as follows. First, the left side limit. So the limit as x approaches 0 from the left of f of x is positive infinity. I want to accentuate the fact that that's a positive infinity because we do have negative infinities. In fact, we'll see that in the next example. Now from the right side, or from the side where the x values are greater than 0, our limit is also positive infinity. So what does this mean? Well, they match. The left side limit equals the right side limit. So we have a limit. So the limit of x as it approaches 0 of f of x is positive infinity. Our final example in this episode looks at another rational function with another asymptote. But in this situation, our left side limit, or I'm sorry, that would be the right side limit, and the left side limit are heading in different directions. So we're heading upward on this part of the function, and we're heading downward on that part of the function. Again, we're going to add a table to help us look more closely at the left and right side limits. We can see that as x approaches 1 from the left side, or from the values of x that are less than 1, we're getting closer and closer and closer towards negative infinity. Our values keep increasing, and they will keep increasing and approach negative infinity. Now on the right side, as we come towards 1 with x values that are greater than 1, we see that we are getting larger and larger and larger, constantly increasing, and this is heading towards positive infinity. So we would write these limits as the limit as x approaches 1 from the left of our function is negative infinity. And from the right side, the limit as x approaches 1 from the right of f of x, remember that was positive infinity, and I'll put the sign in there. So the left side limit does not equal the right side limit. There is a negative infinity that's different than positive infinity. And the left side limit is negative infinity and the right side limit is positive infinity. These do not agree. So we would say that the limit as x approaches 1 of f of x does not exist. So this is an important idea. If the limits, the left and right side limits, match either to positive infinity or negative infinity, a limit can equal infinity. A limit can equal negative infinity. And a limit cannot exist. A limit does not exist only when the left and right side limits do not agree. And that's it for this episode of Math Mountain. Next, we'll be looking at algebraic solutions to limits. So I look forward to seeing you there. Have a great day.